We have put the recording option on. I am Dr. Firdous Ahmad Malik. I will be chairing this session. Unfortunately, our session chair is unable to join us now, but later he is going to join us. Now we are starting our first day session formally. So good evening, everybody. Today we are having our first session of our 1 week international workshop on statistics, econometrics, and data. We are having with us an eminent statistician, Dr. Parmeet, who is working as assistant professor at Patna University since 2022. He did his master's from Pondicherry University, later moved to University of Delhi for PhD in statistics. His area of interest is biostatistics and actuarial science, mainly survival analysis, insurance, statistical computing and software like R, LaTeX, Stata software, and eViews. He has published many research papers, both in national and international journals. Over to you, sir. We welcome you.
Thank you, Firdous, for a very nice introduction. Now, let's start our session. I will be sharing my PPT. It says, is it visible?
Yes, sir, it is.
Okay. So today we will be discussing on the basic applied statistics for empirical analysis. So before we go further, I would like to thank all the organizers, especially Dr. Bhagirath, who invited me for this presentation, and other eminent members, Abdullah ma'am and Firdous. Thank you all, and dear participants. Now, let's start with our presentation. Here we will be learning about the basics of statistics, which we are going to use in econometrics or economics. So economics is very much incomplete, a little incomplete without statistics. And statistics is incomplete without any of its papers or subjects like economics. Because statistics is not just a subject, but also a tool, like a technology. Okay, so like we have science and technology. So science cannot propel without technology a lot much. Okay. So in the same way, economics, if you in economics, if you go faster and further and a little more, then you need statistics at any point of. So basically, these are helping each other to progress further. Okay. Now, my outline will be why we are using statistics, then data and its types. Then we will go for the descriptive statistics, which will be dealing with summarizing of data, then data visualization, then a little concept of probability theory, some distributions, and hands-on session with the Microsoft Fiction. So we will try to cover all these things. If not, we'll try to cover the basic things that can be done, and that will be more useful for the further sessions. Now, let's start. Before I start, I would like to put a question: why you are using statistics? So, is it are the audience are able to communicate? Will they be able to answer?
Yeah, actually, we have put them all, on mute because there are a lot of disturbances going on, and
Okay.
they are,
No worries.
unable to control the mic. So we can take the question and answers at later stage.
Okay, sure, sir. So let me quote one incident, like why statistics. So a few days back, I was watching a movie, Everest. It is on Prime Video. So a group of climbers, they were going for the Everest. Okay. So when they reached the Everest base camp, everybody was asking each other that why you are going to conquer the Everest. So everybody has their own wishes. Somebody has the dream. Someone took it as a challenge. One person told that it exists, so I want to climb it. So it should not be like that. Statistics is the subject. It is existing, so I will learn it. So there should be a proper meaning and purpose why we are going to use statistics or learn. Okay. So first of all, let us see what is statistics. By definition, statistics is the science which deals with collection, analysis, interpretation of numerical data. So why numerical data? Because we cannot analyze a quality or quantity which is not measurable. Okay, so either we will convert it into numerical terms, or we will do something so that it can be captured numerical or quantitative. So it has four parts. Data collection. First of all, statistically, the data should be collected. Data should be collected in a proper statistical method or scientific method, which has a different different topic, that is sampling. That is sampling, which means that how do we collect the data? Then further we go for the analysis. Analysis involves the various techniques and tools which helps us to analyze the data and bring some meaningful examples or insights out of the collected data. Then after that we present it in a way that the audience and the purpose or the objective of the data collection should be fulfilled. And after that we interpret. The last stage is very important, because we are collecting the data and analyzing and presenting it for a purpose. We have an objective. We should not do it without any objective, without any aim. So whatever we are going to do, from starting from data collection to the interpretation, we should have an objective in our mind and we should not deviate from it. Because if we have data, we can do infinite number of analysis out of it. We can do infinite number of uh, results out of it. We can infer anything whatever we want. But if we are going to stick to our objective, then only we will be able to justify our job. Okay. So at the beginning we do the data collection, and at last we do the interpretation. Interpretation is very important, because whatever be the objective, like if we are going to do analysis on, or we have a objective of like how the money is flowing in the market regarding a particular product. So we will be collecting the data only about the particular product. We have the freedom to collect the data about all the products available in the market. But will that serve our purpose? No. It might be deviating from our objective or from our intentions, that why we want to collect the data or what analysis we want to do. Okay. So it is very important that we should stick to the point and our objective. And one more restriction, the biggest restriction with us is, like we have a lot of tools and technology to collect the data, but do we have that much of time, that much of money, energy, resources to collect all the data and keep them and analyze them and infer out of it? Because earlier, like in 90s, we used to produce a lot of data. Okay, lot of data in terms of information, in terms of newspaper, or in terms of the like television or satellite data. So whatever kind of data was developed till 90s, nowadays every hour we are producing that much of data. Okay, so technology has given us tool, and we have they have given us many hands and many techniques to capture data. But at the same time, the difficulty has arisen that how we are going to handle these data. The first and foremost problem is storing them. Okay, so if we are not going to stick to our objective, then what happens is the primary problem will come of data storing. How we are going to store the data. So this is a very broad topic that can be discussed later or in some other things. Okay, now the statistics here. data collection, analysis, presentation, and interpretation. Okay. Now further, based on data collection, we have two types of data. How we are going to collect data for our objective. So there will be two types of data: primary data and secondary data. The primary data is when we are going to collect the data based on our objective from the source, from the actual source. Okay, like if we are going to consider the same example, that for a product we want to analyze how it is working in the market. Okay, suppose for a motorcycle, a TVS Apache. It has started, I think the first model came in 2007 and still it is running. Okay, so how it is working and how it is getting popular and how it is changing the economy, if we want to study. So for data collection, what we can do is, first either we should go to either to customer based on our objective, in which side we want to collect the data or study. So we can reach out all the customers, those who have bought the TVS Apache, or to the sellers, retailers, or the wholesalers that who are selling this bike. Okay, so this is primary data. Primary data. Why? Because we are approaching each and every person and the elementary data source and collecting this. Okay, so it has its own advantage and disadvantages. Advantage is that we will collect the data based on our based on our objective and our convenience. But the problem is it will take time, it will take energy, and it will consume our resources, money, time, and many things. So if we don't want to invest this much of problems or this much of time, then we can go for the secondary data, which is nothing but already data that has been collected by somebody else, and it is already available in form of printed form or digital. We can simply collect it from them and we can make use of it. So it is very clear that what is the difference between primary data and secondary data and what is advantages over each other. Okay. Now, once we have collected the data based on our objective, either in a primary way or in a secondary, then further we can classify the data based on their nature in two categories. That is numerical data or quantitative data. And the second one is categorical or qualitative data. So let's understand what is numerical or quantitative data. Numerical data is like count number of bikes that has been sold in a particular month or particular year or over the 15 years. Like if we think, I'm not sure, but the first bike was sold in 2007. So from 2007 to 2024, it is around 17 years. So we can get how many bikes were sold, how many bikes were like seized due to manufacturing problem, and how many bikes are sold to different economic groups. So based on that, the numbers and counts, whatever we are collecting, that will come under the numerical or quantitative data. Now, further, we can check for the categorical data. Categorical data, it will come as how many persons with name Naveen, they have bought the bike, which color. These things are color, name, and place. So based on that, data are available. So these will be called as categorical or qualitative data. Okay, now further again in numerical or quantitative data, we can again um, classify them as discrete or continuous data. So discrete data means simply the whole numbers or the integers, the integer numbers, whatever it comes in, whatever kind of result, like simply count number of bikes or number of customers, uh, number of customers to a particular model, in or number of bikes that has been sold in a particular year. These are discrete data. Then we have the second one is continuous data. In continuous data, how it becomes like if the results of the variable are in numerical form, in decimal form, like what is the average of the bike which was sold in 2007? What is the average in terms of mileage like how many kilometers it can go in 1 liter. Okay, so based on condition, every year we can check. So the data collected will be, it will not be 4, 5 or 6. It can take value 4.2, 4.5, 35.2, 25.2. So these are called continuous data. When we have all the values possible on the real number lines. Real number lines means it can take the values of decimal. Okay. Now, further we can see categorical or qualitative data. So numerical data and qualitative data we have already discussed. Then we have categorical or qualitative data. Now, in categorical data, we have two types of data, nominal data and ordinal data. Nominal data is nominal values that represents discrete units or label them, and which do not have quantitative value. It is just name, color, or some place, like what is your gender, male, female. Like we can, if we concentrate again on the bikes, we can see that how many female members have taken the bike, how many male members have bought this bike, then what is the color of the bike, then which place it was bought, it was sold. So there is no meaning of male or female. It just categorizes based on quality. Okay, there is no meaning of color. Again, it categorizes based on the quality of the quality. Like it is just a name. Okay. Now, coming to the ordinal data, it is a very interesting one. So it represents a order. Okay, though it doesn't have a discrete meaning. Discretely, it doesn't have a meaning. We cannot infer anything out of it. But we have, if it is kept in one order, then it has a lot of meaning. So you must have you must have done shopping in Myntra, Amazon, or Flipkart. So after buying a product, it asks you for rating out of 5 star. Or some companies or shopping websites, they ask for out of 10. So based on their way of analysis, they consider it 5 star or 4 star or 10 stars, like that. So when somebody looks for a product, suppose somebody wants to buy a mobile phone, so they will be looking at the rating. So if it has 3 stars, then does it have a meaning if there exist only 3 stars? No, there is no meaning, because whenever we are looking at rating, if it has 3 star or 3.5 star, our we will think, okay, so there are some bad products as well which has 2 stars, or there are some good products which might have better rating, like 4 or 5 stars. So like alone it doesn't have a meaning. Okay, but if it is arranged in an order, it will have. So if we go for some checkup, the doctor asks us how you feel, good or bad, we can reply. So individually there is no meaning, but good or bad, if we are going to tell him, so he will compare. If we are saying good, that it means that we are not that much suffering from the disease. Or he can ask how you feel, you can rate based on 10 points. Because how we feel, it's up to it is only for the personal person. This opinion is person to person, and it changes. Whatever kind of pain we are feeling, it doesn't mean that this other person can also feel the same pain. Okay, so some or the other way we want to capture it to understand the level or the robustness. We scale it uh, based on our experiences or numbers. These are ordinal data.
There is somebody named by Balaram. Are you doing it by mistake, or you are doing it deliberately? Kindly stop it. Please
Okay.
go ahead, sir.
Yeah. Now, after going to the nature, after understanding the nature of data, let's further go the type of data which comes under time series data. The time series data is nothing but if we have a collection of data sets based on time, like over the years, over the months, or over the days. If we are collecting the data, then it is called as time series data. It can be on regular intervals or irregular intervals as well, but uh, those coming under the regular intervals, these are called time series data. The time unit of observation could be anything such as second, minute, hours, day, week, or years. Like when we were suffering from the corona times in 2022, we had collected data from second to second. Every second, how many cases are arising around the world, we were recording. So in the same basis, we were recording every minute, every hour, or every day. So I have just kept one small example. Total number of deaths due to novel coronavirus in 2020, and the data was collected from August 27 till August 27 from August 15. It is just a small part of data. Okay. Then we have cross-sectional data. The cross-sectional data are the observation that come from different individual or groups at a single point of time. Okay. So let's consider again the corona data that we were studying at that time. So the corona data was based on the occurrence of cases or deaths or new cases. We were studying on the different geographical regions, like for different countries. We were studying at one single point of time, studying the data for different regions or different categories. This is called cross-sectional data. Then we have panel data. When panel data is collection of data that is collected over the time for the same subject or entities. So it is like in a vague way we can understand that combination of time series and cross-sectional data. This can be a panel data, but not exactly that one. So in panel data, what we collect is we collect data from different categories or different places over the time. It is daily basis, yearly basis, or monthly basis. Okay. Now we have understood the data types and data types based on their nature and based on the other things. Now let's move towards the data visualization. Okay. Before we go to the data visualization, we can think of like in statistics what we did. First, we did the data collection, then analysis, then interpretation, and then presentation, and then interpretation. Okay. So once we have collected the data, there is a small formality that we do, cleaning of data. It's not just a formality, but a very important. Okay. After cleaning the data, we go for data visualization so that we can have a small idea or understanding about our data in a very basic version. Okay. So how do we understand or visualize our data? So graphically, we used to see that how our data looks. It is an attractive and concise pictorial representation of data and information. A picture is considered to be more effective than words for describing a particular situation. Okay. So why we give so much importance to data visualization? So you must be aware of like news TV channels and all. So earlier, what we used to do, we had only one source of knowledge that we came across for the information about our country, our city, or around the globe was newspaper. So we had only one source. So we used to just read, but not everybody had that much time to read all the paper from first to last page. So what we used to do, whatever time we had, we used one paragraph or we particular one section, and in that particular 1 hour or 1.5 hours, whatever time we had, we used to study that and collect information. Now later on, the television and radio got popular, and news were heard on that. So it saved our a lot of time. So the news was playing, and then we were doing our work, and we were able to somehow. Uh, I collect a lot of information from around the globe, national, international news, and other things. So it has also some limitation that whatever the speaker says, we were able to hear. We had we didn't had our own perspective. We had the perception of the speaker, how they are speaking, or be it the newspaper, we had our own perception. We didn't had our own perception. We had the perception of the writer, how they are going to write, how they were writing, and how to understand. Okay, so this is also a very critical point where we can understand about the primary and secondary data. So the newspaper, the TV or the radio, whatever collection of whatever data we are going to collect or hear, these are all secondary data for us. So secondary data has one more disadvantage, that whosoever is going to collect it and present it to us, they will have their own perspective for that presentation or that data. Okay, so if suppose a news anchor, if he is giving the economic data for US, if he had some personal opinion about US, so the presentation might differ from point to point or from situation to situation. Now, nowadays, okay, now coming to the point why I was describing all these things. Nowadays, you must have seen that the news anchors, they are using a lot of graphical approach, lot of graphical representation and data analysis for giving the news. Why? Because earlier they used to give like a table. So, how many of us are interested to read the table and then interpret the data? So, we didn't have time, or maybe many people were not able to quantify this data and understand or grasp out of it. So, what happened? These anchors and TV channels, they used the statistics to display all these huge data points from a single picture, be it graph, be it bar graph, line graph, pie chart, and many more. Okay, so these diagrams, it gives a bird's eye view of complex data. It's very easy to understand for the common man. Long lasting impression, it saves a lot of time. Like if there is a news based on the data, if it is written, it will take around 10 minutes. And if we are going to hear it on the radio, it might take 5 minutes. Okay, but if it is represented very well with the help of pictures, it might take just seconds to grasp it and to understand. And picture the data visualization, the graphical version also helps the layman, the people who can't read, write, or have literature uh, view. So for them also, this pictorial representation is very useful. It facilitates the comparison. We can simply compare from one region to another region, one group to another group, and all those things. Okay. So based on the data, what kind of data we are collecting, we can have these type of graphical representation we can use. So first of all, if we have the data ungrouped, then we will have some set of representation, graphical representation. If the data is grouped, then we will have another set of graphs that can be used. So okay, before going there, let me just conclude in one line how what is ungrouped data and grouped data. Ungrouped data is nothing but just a collection of the data in raw form. Like it will not be summarized. Like if we are going to survey a city having Apache bike, how many Apache bikes are there? So we will be just counting and writing it down. Okay, whatever wherever it found, it will we will just write it one, two, or three like that. Okay, and group data is we will be representing it in tabular form, be it in frequency or in a summarized way. Okay, so if we have ungrouped data, then we will use three type of graphs: line graph, bar graph, and pie diagrams. So line graph and bar graph are basically used for the numerical data. Okay, if we have a lot of frequency and all those things, so line and bar graph are very useful. Like line graph, we can see like in cricket, if two teams are playing, they will put a line graph and they will show that in which over which team had scored more. So it is very clear to understand that how it is going to represent. Then bar graph, it represents the just the number of counts. Then pie diagram. Pie diagram is basically used for qualitative data. Okay, number of males, number of females, or colors. These are the pie diagrams. Okay, then For group data, we use histogram, frequency polygon, and frequency curve. So histogram is nothing but it is also similar to bar graph, but the difference is in bar graph we don't have uh, bin or the intervals. Okay, bar graph may not have a continuous data. It might have a discrete data. So we will be just simply plotting it and representing. But in histogram we must have continuous data so that we can spread it in different intervals and different bins. Similarly, the frequency polygon and frequency curve can be drawn. These things we will see in the hands-on session on Excel. Now, going further, once we have collected the data, we want to see the descriptive statistics. Like descriptive statistics, it contains the very preliminary analysis of our collected data. Okay, first of all, we want to understand the central tendency of our data, like centrally how the data is lying, where the data is lying centrally. It is more or less like balancing a stick at the center. Okay, so where the data is centrally located. So there are different type of methods to uh, to get information of central tendency, or we say it a measure of central location. Okay, so first thing is mean. Mean is nothing but mean is the most popular and well-known measure of central tendency. It can be used with both discrete and continuous data. The mean observation can be calculated by this. Then for the frequency distribution or the group data, we can make use of this the second formula to calculate the mean. Then the descriptive statistics continuing for the median. So median is nothing but the middlemost score of a data set. So the method to calculate median is to simply rearrange the data into order of magnitude, smallest first or the biggest first. Either it should be in ascending order or in descending order. So if the number of counts of the data is odd, then the middlemost value will be the median, and if we have the count is in even number, then the average of the two middlemost values will be mean. Now, again, if we have data distributed data collected in group form, then the median can be calculated from the this formula. Median equal to L plus H by F into N by 2 minus C, where uh, first we choose the median class, then L is the lower limit of that class, then frequency, then H is the magnitude of the class interval. It is nothing but the width of the class interval, then C is the cumulative frequency distribution. Okay. Then similarly, mode can be calculated. Mode is nothing but the number which has occurred most of the time in our frequency in our data. Okay, and for the frequency distribution or the uh, tabulated data, we have this formula for calculating the mode. It is more or less likely like similar to median. Okay. Now let's differentiate between mean, median, and mode. Why we have three different or more than that, more than these descriptive statistics or central tendencies. Okay. Now mean is okay. It is very idle for calculating the central tendency. The mean, but it's not useful all the time, or not median is also not very favorable every time. Sometimes, depending on the situation, make use of the different central locations, mean, median, or mode. Let's take an example of mode. Okay. So, have you noticed that when you go to the market, and if somebody has a leg size of foot size of 11, so it's very difficult to get a shoe. Is it like there are more buyers of size 11 or 10 as compared to size 7 or 8? No, it's not like that. Based on the population and a median sample size, these manufacturers collect data that how many people are available of a particular size. So based on that survey, they found that people have very frequent number size of 7 or 8 for male. So they will produce more and more number of shoes of this particular size. And they found that there are very less number of people having a number size of 10 or 11. So they will manufacture it very less. So what happens if they will we will have a shortage of number 10 or number 11 shoes very soon. Okay, but whenever you go, number 7 and number 8 will be available anytime you go to the market. Okay, so here we make use of mode for central location. So here if we take the example of size of shoes, so the measure of central tendency will be mode. Why? Because the manufacturer want to sell more shoes. So these are the more number of people of size 7 and 8. Okay. Now, where we use median. Median can be used used for the age group of a particular category or particular region and all those things to understand the nature of the society and to make policies for the particular society or the place. Okay. Now, let's see which one is best among these three. So there are some characteristics proposed by you, rigidly defined, whether the central tendency is rigidly defined, comprehensible, easy to calculate based on all the observation, all those things. Based on all, the mean qualifies most of the characteristics, whereas median and mode, they qualify very less number of characteristics per. So we call mean as a ideal measure of central tendency. But it doesn't mean that every time, wherever we want, we can use mean. Be it counting of trees. What is the if somebody says what is the average number of trees in a jungle? So we cannot say that this particular type of tree or 3.5 is the average number of tree. So again, we will come to the mode, that which is the highest number, which variety of tree is occurring highest. Okay, so if neem is the tree which is occurring highest, so our average or central tendency for that particular forest will be neem, and this information came from mode. Okay. Now, these were the till now we have seen the central tendency. Okay, now we will be looking at the dispersion, the spread of the data. Central tendency gave us the idea of concentration of the observation about the central part of the distribution, where the dispersion means the scatteredness. It gives the idea about homogeneity or heterogeneity of the distribution. We see that how much the data is spread. Okay. It gives the idea about the about the spread of the data, how much it is scattered from a particular point or from different directions. Okay. So for calculating the dispersions, we have partition values, range, quartile deviation, mean deviation, standard deviation, variance, coefficient of variation, and other things. So in partition values, we have quartile, decile, percentile, and all those things. Range is nothing but the highest value minus the lowest value. How much the data is spread. Okay. Then quartile deviation, deviation between the two quartiles. Now, to understand the data, how the data is spread, we had a tool called mean deviation. Mean deviation used to find out the spread of all the data from a particular point A. Okay. So when we started first, we didn't use the this modulus. So what was the disadvantage of that? We had some positive value, we had some negative value, because from a particular point, if we take A, and so differences of the x size, it might take positive value or negative value. So after summing it up, you can see clearly from the formula that we take the differences and sum up, and then sum up. So what happens if we don't use the modulus? So that positive and negative terms, they will cancel out, and it may come that the mean deviation is 0. But in reality, it might not be. Okay, so it has this disadvantage. So to overcome this disadvantage, we went for the standard deviation. In standard deviation, what we did, we simply used a particular value called mean. Okay, so we used to calculate the deviation from mean instead of any arbitrary point A. So this became as standard deviation. But one more thing we did earlier in mean deviation. What was the disadvantage? That whatever value it came, we used to keep it positive. We used the modulus and we just made it positive forcibly. So we lost some of the data, or some information was lost. But in standard deviation, what we did, we squared it. Whether it is positive or negative, we squared it. So we got the positive answers only without losing the information. And in the last phase, what we did square root. So we got the information in two ways, one in positive terms and one in negative terms. So the deviation of the data can be from negative side to positive side. We had a range that the spread of the data will be in this particular terms. Okay. So again, the standard deviation had a disadvantage that it went from both the directions. So collecting the information was a little difficult. So we went for the variance, which had always positive value. Okay. So this was the evolution for calculating the spread or dispersion. Now, these were these deviations were calculated only for a single time series data, or sorry, a single series of data, univariate data, or a particular set of data. So okay, now what happens if we see that we calculate variance of one series of data? It has, suppose it has 5, and another series of data it has 10. So can we say that the variance of data 1 is better or data 2 is better? So we always want to reduce our variance. So as per that concept, the deviation of series 1 is 5 and another series is 10. So we can say that series 1 is better than series 10, or series 1 has more consistency than series 2. But we cannot say it like that, because depending on the nature of the data, the data points, the variance will change, or it will have another impact. Suppose this might happen that data points in series 1 is only single digit data, so it has 5. Okay, and in this might happen that in series 2 the data points are 3 digit data. So for 3 digit data, deviation of 10 is not very big. Okay, but for a single digit data, if deviation comes to 5, then it's a very big variation. Okay, so to overcome this problem, we made use of coefficient of variation. It is unitless quantity. It used to compare the variability of two series which differ widely in their average and measured in different units. Okay, so if we had a time series in kg, or data series in kg, and another in centimeter, so we cannot uh, compare them. So we had coefficient of variation. Using this coefficient of variation, we can compare these two different series, because the measurement is done unitless. Okay, it's simply standard deviation by mean. So change of, so it is from their mean how much standard deviation is calculated. Okay, it is simply like a rate of change of standard deviation per mean. Now after that, once we have seen these variations, then we want to study the nature of our data based on skewness, whether our data is skewed in one side or in another side, or if we see that in the center, the middlemost figure. So if we plot it on the basis of normal distribution, we see that our most of the data is concentrated on the middle, at the middle, and on the both left and right side. the concentration of data is reducing. Okay, so the middle one figure is said to be symmetrical data. This doesn't have a skewness. It will have a skewness 0. Okay, here the mean, median, and mode will be equal, the same point. Now, if we come to our left side, it means that the in the left of the data points, the data points will be very less on the left hand side. Okay, so it has a very tail kind of structure. Okay, and the peak is on the right hand side. So the peak represents the mode, the most of the mostly occurring numbers, which is occurring frequently, that is mode, and mean will be on the left side. Similarly, on the right side, we can see that tail shape is going towards the right, and the peak is on the left side, that is mode. Okay, so on the left figure, when the mean is on the left hand side, it is called negative skewness or left skew, or if the mean is on the rightmost side, we say that it is positive skewness or rightly skewed. Okay, so this gives us idea of how the data is skewed in any one direction. Now, there is one more way to understand that how much the data is uh, concentrated at one place, either it is in lower or in higher. It gives idea that most of the data points are repeated at a single point, or they are spread over the places. So kurtosis gives the idea of flatness or pickedness of the frequency curve. So we can see that consider there are three types of curves: platycotic, mesocotic, and leptocotic. Consider that mesocotic is the normal curve that we can get out after plotting a series. So for mesocotic, the kurtosis is 0, however, whatever we consider. Okay. So if we find out that the frequency of the data is like mode of the data is lower, so the flatness, the pickedness will be lower. So it is called platycotic, and it has kurtosis less than 0. And if the mode is mode, so the peak will be higher. So it is called leptocotic, where the kurtosis is greater than 0. Those who are interested, they can take up this one and they can study a little more. But I have given just a small idea about how kurtosis is working. Skewness and kurtosis are given. Now, I hope till here it is clear. Before
Yes,
we
sir,
go
everything is fine.
just 1 minute.
Okay. Meanwhile, I want to, again, we are following serious discipline. So therefore, you have to not play with your mobile phones or laptop unnecessarily. So it disturbs us. So continue, sir, please.
Parmeet sir, Firdous sir, if I take just 30 seconds.
Yes, please.
Uh, Participants, this is a very critical discussion going on, and Dr. Parmeet is converting a very large amount of literature and technical concepts into small nuggets. He will definitely be sharing presentation, and I and Dr. Parmeet together have discussed and prepared a reading reference also for you. So prepare based on that also. These are very fundamental concepts. Without knowing this statistics, how statistics works, how data is conceptualized in statistics, you won't be able to make sense of further session. So after the session is over, make sure to sit down and study. We'll send you something to read once the session is over. Sir, please continue. Thank you.
After the session gets over, I will send you this slide, and along with that, I will send you a notes also. Okay, that will be very useful for you people. And these are just the basics and fundamentals, as Bhagirath sir has mentioned. So if you are able to grasp these things further in the workshop, it will be very helpful for you all. Okay. So now moving forward towards probability theory. Okay. So probability theory is developed to understand the nature of probability, or whatever we want to calculate probability in terms for any event or whatever kind. If we want to know that what is the probability that tomorrow is going to rain, we need some data. Okay, based on that we will be telling you whether tomorrow the probability of raining is 1 or 0 or 0.5 or something like that. So based on that, uh, there are three definitions of probability based on the different approaches and usefulness. Okay, so first, the very foremost and first theory was developed based on classical or mathematical or a priori definition. Okay, so what happens here is, okay, there are three: classical definition, statistical or frequency, or posterior definition, and the third one, which is called very modern, it is axiomatic definition. Okay, so one by one we will study that. So first is classical or mathematical or a priori definition. In this one, if a trial results in n exhaustive, mutually exclusive and equally likely cases, and m of them favorable to the event E, then the probability P of happening of event A is given by favorable number of cases by exhaustive number of cases. Like suppose, again, let's come to the example of Apache bike. If a person wants to buy a bike, so we want to know that what is the probability that this person is going to market and he will buy Apache bike. Okay, so what we will do is we will collect the data that how many people have bought a bike and how many of out of these people have bought Apache bike. Okay, so suppose there are 20 kind of bikes are available in the market, and they have all of them has equal offers and equal rates. Okay, in that segment. So what is the probability that a person going to the market, he will be buying a Apache bike? So we will look at the data that how many in previous years, how many people have bought Apache data, and what is the total number of sales of different bikes. So suppose 10 people have bought Apache bike and total sales were 50. Okay, so 50 includes the number of sales of these Apache bikes as well. So it will be simply 10 by 50. Okay, one can interpret that the odds in favor of E are m by n by m, or odds against E are n by m by m. Okay, so these are little mathematical terms. So, but it's very easy. We will send you the notes and you can go through it. Okay. Now coming to the statistical, the frequency based or posterior definition. Okay, so here also the things are same as the classical definition. Statistical definition and classical definition, both of them are very similar, but the difference is when the number of samples or number of events gets very large. If a number gets very large, we call it as moving towards infinity. Okay, so for again we come to the example of the bike. If we see that if we want to calculate the number of sales of bike or probability of selling an Apache bike, then it's very easy for us to calculate. Okay, because we can count it, right? Suppose we want to calculate what is the probability that tomorrow there will be a star falling to us, or what we call it, shooting star. We can see the shooting star. Okay, so can we count the number of stars in the sky, or do we have any information that in 2 years how many shooting stars were visible from the Earth? Okay, it's very difficult. So what we do is we simply put an infinity, n tending towards infinity. N is what is n? N is simply our number of stars, and m is how many shooting stars were seen. So n we cannot count. So we simply say that n belongs to infinity. So this is the whatever kind of information we had. Based on that, we do. Okay. So what is the basic difference? So the difference is number of favorable events and number of possible events. Okay, so this creates the difference between the classical and statistical definition of probability. Okay, and one more very interesting example is in classical definition. It says that if okay, let me take another example. If somebody produces a bulb. Okay, so if we are interested to know that what is the probability that a bulb, if it is fallen from a height of 3 centimeter or 5 centimeter, be it 5 centimeter, so what is the probability that it will break? So according to classical definition, how we will be calculating it, whatever number of bulbs we have, like 1000 bulbs was manufactured by a factory X. So how we will calculate it? We'll drop all the 1000 bulbs and we will check that how many broke and how many didn't broke. Okay. So whatever number of bulbs were broken, okay, that will be our favorable cases, and total number is 1000. So suppose 30 bulbs broke. So 30 by 1000, that will be the probability in classical definition. Okay. So this was the classical definition of the probability. But what is the disadvantage? The disadvantage is we have to test each and every product in that. Okay. So is it possible for every product to be tested like that? No, it's not. And what if it breaks? It will be a very loss. It will be a big loss for the manufacturer or the investors, those who were investing in that particular manufacturer. Okay. So the statistical definition was superseded this. Okay. So what they did, they took just a small sample out of 1000, they took 100 and they did the test and they interpreted it. They just made their inference based on the 100 for the 1000. So we had to test only 100. This gave us advantage of loss for reducing our losses and reducing our time as well. Okay. So after these two, we have the third version, which is axiomatic definition. So axiomatic definition, it has three approaches. One, three conditions are there. Okay. So first is axiom of non-negativity. It means that probability cannot be negative. So the range of probability is 0 or 1. It cannot from 0 to 1. It cannot be negative. Okay. Because if we say that what is the probability that tomorrow it's going to be a world war, so either it will be 1 or 0, or based on the scenario we can have 0.1, 0.2. It cannot be negative because there is no sense of negative probability. Okay. Then there is the another one. Next axiom is axiom of certainty. It means that if event is going to be sure, it has its probability is 1. Like tomorrow, whether the sun will rise or not, everybody knows it will rise, whatever happens. Okay, so this is sure event. It is 1. Okay, then axiom of additivity. Probability of two mutually exclusive events can be added. Okay, if the two events are mutually exclusive, then it can be added. Okay, so going further, we majorly deal with the three theorems. The theorem one says the probability of impossible event is 0. Okay, somebody if asked that what is the probability that the sun will rise in the east, so it's not possible. So it's always 0. And what is the probability that tomorrow Himalayas will go vanish? So it's not possible. This might take years, but tomorrow it's not possible. That is for sure. Okay. So it is impossible event. So the probability of vanishing of Himalayas tomorrow is 0 or another. Okay. The second theorem is probability of complementary event. So complementary event we denote it by A bar. So complementary event is given that probability of A complement is 1 minus probability of. Okay. So suppose probability of raining tomorrow is 0.7. That then the probability of not raining will be simply 1 minus 0.7. Okay. Then the theorem 3 is if A and B are two events and are not independent, then it will be given as probability of A union B equal to probability of A plus probability of B minus A intersection B. What is intersection? Intersection is the common part between them. Okay. So it is simply we will be adding the probability of two events and we will be subtracting the intersection part. Intersection is nothing but the common part. Then further we will see the conditional probability. consider the conditional probability of an event B is the probability that the event will occur given the knowledge that an event A has already occurred. This probability can be written as probability of B given A. That it means that what is the probability that B will happen given that A has already occurred. Okay, it is nothing but probability of uh, happening of A and B simultaneously by probability of A. Okay, so let's take an example. What is the probability that tomorrow it will rain and we will have an umbrella? Okay, so something like that. Then independence of event. An event A is said to be independent of another event B if conditional probability of A given B is equal to unconditional probability of A. That is, A given B is equal to probability of A. It means that if an event A and B is independent, it means that there will be no intersection. There will be no common part. It will be simply uh, like intersection will be 0. Okay. So it is also mentioned here. So this is the independence of A1. Now we have Bayes theorem. Bayes theorem is something likely reverse of the conditional probability. Okay. In conditional probability, we give a condition and we ask what will happen. Okay. But in Bayes theorem, we do it reverse, other way. That this has happened, calculate the probability or find out the probability that this was happened. This could have been happened. Okay, so it is a we know the future and we want to know what is the past. This is Bayes theorem, and in conditional theorem we can understand that conditional probability we know the present and we want to know the future. Okay, so in Bayes theorem we simply want to know about different scenarios for the future event. Okay. Now I think we have reached 7:45. So I will try to wind up little quickly and then we will go for the Excel session. Now I will summarize quickly the distributions. Why do we need distributions? Okay. So again, first go to the first slide that we discussed about what is statistics, data collection, then analysis, then presentation, then interpretation. Okay. Once we have collected the data, and if we have a small amount of data, we can understand and we can do the interpretation or analysis based on the nature or whatever be the our objective or necessity. But is it possible to do it every time if the data is very huge? If we have a lot of enormous amount of data, so it's very difficult to analyze them and then interpret data. And if we have, suppose we have repetitive work, similar kind of work, we have to do it again and again, again and again. So every time do it from scratch, it's very difficult. So we have distribution. So what distribution does is it helps us to understand the pattern or nature of the data. It is already built in. So we try to fit the data in this type of distributions and we can infer a lot of information out of it. It saves our time and energy. Okay. So we have two types of distributions uh, and one more is sampling distribution apart from these two. First is discrete distribution and continuous distribution. One is Bernoulli distribution. It is single trial with two possible outcomes. In Bernoulli trials, we have an event and that can have two possible outcomes. Okay, like flipping a coin, it will have only two chances, either head or tail. Okay, then we have binomial distribution, a sequence of Bernoulli event. Like if we are flipping a coin only once, it is a Bernoulli event. But if we are flipping a coin more than one and collecting the data, then it is binomial distribution. Okay. Then one of the very important distribution is Poisson distribution. This is that if an event occurs very rarely or may not occur, then we make use of Poisson distribution. Like Poisson distribution is useful when we want to study the number of accidents. Okay, So number of accidents is not very not of very much interest of us, but for the insurance sector, it's very useful. Okay, based on the number of accidents only, they have curated the insurance premium. Okay, that's why they are giving accidental coverages, because they know that these events are very rare. Suppose you whenever you go to the your institute or wherever to the market, do you think that every time you go and there is an accident? No, it doesn't happen. Okay, so maybe in months or years there will be one accident, but daily there are thousands and lakhs of motorcycles, four wheelers they are going, but accident is very rare. Okay, so to overcome this problem, we make use of Poisson distribution. Okay. Then further we have continuous distribution. It has a normal distribution, student t distribution, and exponential distribution. Normal distribution is symmetric distribution of values around the mean. The skewness example we saw, that normal distribution represents same kind of curve. Okay. Uh, then we have student t distribution. We make use of small sample size approximation of a normal distribution. Then then it converts to t distribution. Okay. Then for in t distribution, we make use when we have small sample size data. What do we mean by small sample size? If the sample size is less than 30, then we consider it as small sample size. Okay. And if it is bigger than 30, then it is large sample size. So whatever kind of whatever kind of test we do in small sample size, we make use of t distribution, be it testing of proportion, testing of mean, or some other thing. Then exponential distribution, it is model elapsed time between two events. If we want to study the time between two events and elapsing of times in two different series, then we make use of exponential distribution. Further, if we look at a very important distribution, that is F distribution, it describes the ratio of two estimators of sigma square. Sigma square is nothing but the variance. Okay. F distribution is commonly used in statistical analysis to compare the two variances of two different populations. For example, it can be used to analyze the variances to test for the differences in mean or three or more groups. For if we are going to test for the two groups, mean of the two groups, we make use of t-test. Or if we are going to test single mean, then we use t-test. But if we have more than two, that is three or more, then we make use of ANOVA. And there we compare it with the help of F distribution. Okay. And it is very useful in regression analysis to test the overall significance of regression model. In regression modeling, we make use of the different kind of variables, and we go for the testing. So here F distribution makes a very significant role. Okay. Now coming to the chi-square distribution. The chi-square test is done to check if there is any difference between the observed value and the expected value. Okay, so what we do is for any objective, if we have any objective, we want to know that whether it has goodness of fit or test of independence. So what we do is we have some collected data. What is the frequency of data in actual and what we are going to expect. Okay, so the difference between these two expected and observed data is basically nothing but the chi-square test. So the two main types of chi-square tests are test of independence and goodness of fit. In test of independence, we see that whether the two data sets are dependent on each other or independent of each other. Then goodness of fit, whether the data fits the given distribution or not. Okay, so we have very less time, so let's move on to the Microsoft Excel session. The Excel sheet is visible.
Not yet, sir. You have to stop this presentation then, I think. Or you have to share the entire screen. Then that will be appearing to us.
Now,
Yes, now it is visible.
I think most of us are very much familiar with this Excel sheet, and we all know about how to create, how to work with the Excel. But I will just simply go through it. So first of all, the data, you, yeah, the data graphical analysis. Whatever we do graphically, how we represent our data. So here we have a lot of options to go for the charts. Yeah. We have a lot of option with the chart type of chart, that 2D, 3D, and other kind of bar chart, line graph, and histogram, and other things we can see. Okay, so I will just check with one data set. This is the data set shared by Dr. Bhagirath. Thank you for that. So if we we will go quickly with some of the data representations, the graphical methods. Okay, so one very nice tool is that we can get a recommended chart. Okay, here simply it will show what kind of graphs you want. So based on your need and the suitability, which one you like, you can simply plot it. Okay. Then we have very small things like here we can do some an average number of counts, maximum, minimum, and there are a few more functions. Now I want to show one part, that is data analysis. Okay. So here it's not visible. Okay. So how we enable it? Simply we go to the files, options, then add-ins, then Excel add-ins. Okay. Go.
Sir,
Check.
kindly share data set again.
Now here we have data analysis. So this is the way how we do it.
So, yes, Dr. Parmeet, can you repeat it for the participant?
Yeah, sure, sir.
Yes.
In the data menu, it is the data set is the data analysis tool will be enabled. How to enable it? I will just show you once again. Go to the files, then options, then come to the last but one, add-ins. Okay, then in manage, there is simply, it is already chosen Excel add-ins, and click on the go. Okay, the go button. On the go button, you will be given an option for which add-ins you want to make use of. There are several. There are 4 types of add-ins are available inbuilt in the Excel. Analysis tool pack, then analysis tool pack VBA. This is Visual Basics. Then Euro currency tool, then solver add-ins. For now, we need only one tool, that is analysis tool pack. Okay, just simply click it for enabling it. And in data analysis, in the right hand side, you will get a tab, data analysis. Okay. So now in data analysis, if you click, we will have lot of options for statistical and for econometric analysis as well. These are mainly statistical analysis only, but you can have some of the econometric things as well done. Like for ANOVA, it is available for single factor, for ANOVA with two factor with replication, then ANOVA two factor without replication, then correlation, covariance, and descriptive statistics that we have already covered. These things you can get easily from here. Then exponential smoothing, this is that will come under the time series analysis. If we have time series data to overcome the seasonality or trend, we make use of this. Then F-test, to sample for variations, to sample test for variance. Okay, then Fourier analysis, and we can plot histogram out of it. Then moving average method, that is used for the in the time series analysis. Then random number we can generate. Simply it will ask for the range from where to where you want to generate the random numbers. Okay. Then rank and percentile we can calculate. Then we have regression. Okay. Then sampling. Sampling also can be done. Sampling is nothing but collection of method to collect the data. Okay. So sampling, I was not able to cover sampling in that because it was a very short time. But I will just make an introduction of it. Sampling is nothing but technique to collect the data, so that our objective fulfills with scientific method. Okay, so sampling is can have there are several ways to do sampling. One is simple random sampling. It is nothing but the lottery method. Then systematic sampling. Random sampling and systematic sampling both are same, but just the difference is in random sampling we choose the elements or the individual every time randomly. Okay, but in systematic sampling, what we do randomness only once, and then after that we set a range that after 10 we will collect that. Suppose we have a table of random numbers, it is printed in that, or the individual quantities we have enumerated it. So randomly we will choose one, and we will simply add one number, and after that number, whichever comes, we will collect it one by one. So in this one we had to do it only once. Okay, then we have stratified sampling, and then we have cluster sampling. In stratified sampling, what we do is in random sampling, it is okay that there is no biasness. But what if there are several groups of information for the individuals, and if we do random sampling, this might happen that one type of group doesn't cover, is not covered. Okay, so the representation won't be there. Okay, suppose if we have different economic group of people from different economic group. Okay, based on their salary. So if we do random sampling, that how many of them have bikes or something like that.
Sir, one small request I am having. Can you share this data set in the chat box? Some of the participants they are interested to practice with you.
Yeah, sure. I think Dr. Bhagirath, he will be sharing it with everyone.
So he has left. If it is possible right now, you can share in the chat box.
Okay,
So
sure.
that some of the interested students they are participants. They want to practice with you.
Okay. I will do it.
Yeah, Dr. Parmeet,
So,
I have the data. I am sharing in the chat, WhatsApp chat.
Okay.
That is
Okay,
fine.
sure.
Okay, Dr. Malik?
okay, sure.
I'm doing it immediately. The participants who are interested can start using.
Mhm. So let me summarize the sampling thing. So what happens if there are different economic group of people, and again come to the bike selling. Okay, so which category has more number of bikes? Okay, so if we do sampling, so in randomly this might happen that a particular range of economic people, they are skipped, that group is totally skipped. This might happen. So the random sampling fails here. Okay, so to overcome this thing, what we do is we stratify. stratify. Suppose we have three income groups. Okay, so we will make three strata based on the income group. And what we will do, if we have to collect 30 samples, then we will take 10 samples from each strata. So there should be a proper representation. Okay, now every time it is not possible to make strata. Okay, why? Because here we have taken example of economic group, so we know how to categorize them. So we have categorized and we did our job, so that the sampling is homogeneous, the data collection is homogeneous. Okay, now not every time it is possible, like if we want to study the intensity of the stars, okay, or like interest in any product from a particular village or villagers. Okay, so it is not possible to collect all the villagers based on their income group or some other category. So what we do, based on their region, we sample the data and collect information. Okay, that is called cluster sampling. The strata which is made based on their natural habitat. So that is cluster sampling. Okay. Now coming back to the data analysis. So we were sampling. Now here t-test is there for pair to sample for means. Then t-test for two sample assuming equal variances. Then two sample test for unequal variances. And z-test for two sample for means. Okay. Now one by one we will look at it. Okay, for here we have suppose we want to do the descriptive statistics. We want to see the descriptive statistics for the particular data set. Okay. Now simply go to the data analysis and choose descriptive statistics and click OK. Now it will ask you to input the range of data set you want to calculate the descriptive statistics. Okay, so here just click button, it is blinking, and then choose the data series you want to know the descriptive statistics. Like I have chosen the last option, the last variable, non-interest expenses. Okay, so just I have taken the values from 2000 to 2021. Okay. So here they are asking that data is how the data is grouped, column wise or row wise. So here the data is grouped on column wise. Then it is asking for label in first row, whether your data has labels in first row. So yes, we have label. The first row has label no interest expenses. So just click it. Okay. Now where you want your output. Okay. So here we can either we can give option for the new worksheet or in new workbook, or in the same sheet we can mention the range where we want to take our output. Like output range, we just click here and select a point particular. We have chosen output range at I3. Okay. So here what we did, we gave the input range, the series we want to calculate, this summary statistics or descriptive statistics, then label in the first row, and then option where we want the output. Okay. Then after that there are some few more options to which what are the things that you want to display: summary statistics, confidence level of mean, kth largest, kth smallest, and all those things. We will just simply click on summary statistics. Okay, and simply click OK. So we can see that the point where we have clicked, we gave the point for the output. The output has came. Okay, so mean is there, standard error they have given, median they have given, mode they have not given, not available because there is no repetition of data. Okay, all the data points in this variable are unique, so that's why there is no mode. Then they have given standard deviation, then they have given sample variance, then they have given kurtosis. Okay, so kurtosis you can see negative. So kurtosis is negative means left is skewed. Okay, sorry, negative means it is plateau coating. Okay, Then skewness is negative, so it is left skewed. Then range is 14 lakh 65,000. Sorry, 1,46,521. Okay. Then minimum, then maximum value. So in this range, what is the minimum value and what is the maximum value they have given? Then from here also we can calculate the range. Okay, maximum minus minimum. It's very simple. Then total sum of these values, whatever values we have selected. Then count how many data points are available. Okay, so these many information we can get from the descriptive statistics. Right. Okay, now going to the next one. we in graphical, we want to see the histogram of the same data set. Okay, so again, the dialog box has opened. Input range, we will choose the same one. Same range we have chosen from including the label, the title of the variable 2002 to 2021. Okay, so bin range is nothing but the interval, the continuity, the interval you want to give. So if we leave it, it will fill something by default. If you want to give a particular range, you can give that as well. Okay, then it is asking labels. We had label, the first row is label. Okay, again output range, whether you want to take the output in the same sheet or in another sheet or on the another workbook. Okay, so after that again we will choose here the we will do it in the same sheet. We have given the output range L3. Okay, so from here onwards the output will be coming. So now there are multiple options for us that what kind of histogram we want to see. Pareto sorted histogram, cumulative percentage you want to see, chart output you want to see. Okay, so let's click all the options. Let's see how it goes. Click OK. So this is the histogram. Let me magnify it a little. So we can see that they have the result is based on table as well. Table also they have given, and pictorially also they have represented. Okay. So first let us come to the table. They have given the bin range. This is the bin. Okay. From 2,04,067 to 3,13,000. Okay. So what is the frequency is? What is frequency? In this given range from here first to second, whatever number of frequency is occurring, they have given the count. And between these time range, between these, what is the frequency they have given mentioned here? Then again, similarly like that, how much is the frequency they have mentioned? So how many data points have occurred between these things, between these range? It has came here. Okay. Now coming to the picture. Okay, now the histogram is plotted in equal intervals, so we can see that how many data points are available in this histogram. Okay, so this is our histogram that has been plotted by Excel. Now moving to the next one, we want to do t-test. Okay, or something else we want to see. Okay, let's go for the t-test. It has t-test paired two sample for two means. Okay, paired t-test is if we have data from single experiment before after like that. Okay, so we will not be going for this. We will just simply go for t-test with two sample assuming equal variances. Okay, now for t-test the dialog box has opened. So it is asking for variable one range. Okay, since we are going to do sample for two sample tests, so we will give them two ranges. Suppose first is total equity and second is non-interest expenses, and we will understand whether there is any difference between their means or not. Okay. First is total equity. Okay, we have selected, and variable range 2 is non-interest expenses. Okay. Hypothesized mean difference, if you want, you can give, otherwise give it. Labels we have in the data. Alpha we have 0.05. Output range, again we will choose the same page. Okay, let's choose it. And then, okay. So this is the two sample test, two sample t-test. Okay. So here we have mean, variance, and number of observation, pooled variance, hypothesized difference of mean. So by default, it will take that there is no difference in the mean. So difference is mean is 0. Okay. Degree of freedom 42. T statistics calculated is 10. Then probability of the t test value is one-tailed is 4 point something e to the power minus 14. That is, this value is very small. So critical value for this test is 1.68, very less. So now, if we look at this value, this p value for one-tailed and for two-tailed, these are very small. Okay. So what we do usually is we reject the null hypothesis when the p value is less than 0.05. Okay. So this is much smaller than 0.05. It will be like 0.00000 14 times and then 4. Okay. So it is very much smaller than 0.05. So what we do is we will simply reject the null hypothesis. What was our null hypothesis? That the mean of these both the time series, both the series are same. Okay, there is no difference in mean of the series. Okay, but the p value is less than 0.5, so it is rejected. So what we will conclude, that there is a difference in mean of these two values. Okay. Okay. So in this one, anyone have any problem?
If anybody is having any problem, they can write in chat box or simply raise the hand. Once we permit, then they can speak.
Okay. Arshia Sultana has asked why only one tail p value is considered. No, here the result given is for both the sides, one-tailed and two-tailed both. Okay. Depending on your need, you can consider it, be it one-tailed or two-tailed. If we are going to consider that if our okay, once again, okay, I will explain the interpretation once again. If our hypothesis is that they do not have any difference, okay, so it means that suppose the mean is for one variable it is mu1 and for another it is mu2. Okay, so if we see that our hypothesis will be the difference between these two is 0. Okay, our hypothesis d is equal to mu1 minus mu2. If it is 0, it means that our hypothesis is that there is no difference between the means, that is both the means are equal. But is it possible to is it possible that these will have the same mean? Not possible, not every time. Okay, this might be less than that or more than that. Suppose one has 5 and another one has 10, or one has 10 and another one has 11. So difference might be 0, -1, or +1, or 2 or 5, anything. Okay. So our concentration, our area of interest is that we have like we have hypothesized that there is no difference. Okay, if there is no difference, then well and good, we will go with our hypothesis. If it is not, if we are going to reject the null hypothesis, then there are two possibilities. Okay, either the difference will be negative or in positive. Okay, so the data set might go, the difference might go in two different ways. Okay, either in positive side or in negative side. So here we make use of two-tailed test depending on our hypothesis. Okay. Then again, if we are interested that our null hypothesis is that the difference will be positive. Okay. Suppose that our hypothesis is mu1 is greater than mu2. Okay. So we have already set a direction. Okay. If if we find that mu1 is greater than mu2, then our null hypothesis will be accepted. Otherwise, now what will happen? The alternative hypothesis will be mu1 is not greater than mu2. So if we have only one direction, either it will be less than that or it will be greater than. Okay. So less than that is already in our null hypothesis. So for alternative hypothesis, we have only one option. But in the earlier case, what happened? We were taking that there is no difference. It means that in null hypothesis, the difference was 0. But at the same time, the alternative option had two. Either it will be positive difference or it will be a negative difference. Okay. So similarly, uh, we have this two-tailed or one-tailed value. And for both the cases, if the p-value is less than 0.05, we reject the null hypothesis. And if it is greater than 0.05 or equal to 0.05, we accept the null hypothesis. Okay. Or we simply say that we do not have enough evidence to reject the null hypothesis. Is hypothesis necessarily taken? Yes, it has to be taken necessarily. Then only we are going to test. If we do not do any hypothesis, then why we will be testing it? Okay. Now, I hope this one is clear. Moving on to the next test. We will again go to the data analysis, and then we have less time, so we will going for the regression. Okay, we will see for the regression. Okay, now in regression, what we do, we run a regression on one variable or another variables. That is, one is dependent and others are independent. So we want to study that how one variable, the dependent variable, varies as per the independent variables, or how a dependent variable is explained by the independent variable, how it is possible, how they are able to explain the dependent variable. Okay, so for regression, what they are asking, so first of all we have to input the y range, the dependent range. Okay, so let's see that we want to study the total outstanding deposits with the commercial bank. Okay, we want to study that outstanding deposits of a commercial bank, how it is affected or how it is explained by other variables like outstanding loans, then net income, total equity, non-interest expenses, how these variables are able to explain the outstanding deposits. Okay, like suppose there is a situation that a bank wants to calculate its outstanding deposits with the commercial of the commercial bank. They want to find out outstanding deposits, and they don't have enough data, or they don't have that exact data. Okay, or maybe they want to predict for the future that what could be the outstanding deposits if they do not have a particular data, but they have other data sets: outstanding loans, net income, total equity, non-interest expenses, and all those things. Okay, so let's choose what will be our independent variable, that is y range. So let's choose this. Okay. Then input range. Input range, we will choose all the variables that we want to study. Okay. We have labels. Labels simply means the name of the data sets, the variables. Okay. Then output range, again it is asking, we can okay, from this we will try to do it in another sheet, new worksheet. Okay. Then if we want to see the residual plot, line fit plots, then standardized residual, normal probability plot, we have lot of options. Okay. So here we will simply just see for the residual and its plot. Okay. What is residual? Residual nothing but the difference between the expected and actual value of y and expected value of y. Okay. Just we have given all the data points, range, y range we have given, x range we have given, we have chosen the level, then we have chosen the output in a different sheet, and residual plots. Okay, this is the result that we are getting. Hmm. Okay, first we see the regression statistic, what and all they are giving, what and all information we are getting. First is multiple r. Okay, then is r squared, then adjusted r square, then standard error, then number of observations. Number of observation is always 22 because we have data set with a range of 22. Okay, then multiple r and r square. R squared value explains us that what is the percentage of y that is explained by our variables. Then adjusted r square is it's simply what it does. It excludes the variables which has least contribution in this. Okay, so which doesn't affect much, because if we have more and more number of variables in our model, so it will be very difficult to explain. Okay, always we will face difficulty in explaining the data set, and it will be, our data set will be more dependent on other data sets, and this will bring the problem of multicollinearity and other things. Okay. These things you will study in the later sessions of the workshop. Now, in the regression, it is ANOVA. They have mentioned the F test here for the regression F test, and the significance is 0.0071. Again, it is less than 0.05. Okay, we will by default we will always compare our test with the alpha level of significance 0.05. Okay, unless it is mentioned by the examiner or by the situation. Okay, so this model is acceptable. Now, coming to the model, we have intercept, then y, depending on the four categories, the four variables that choose: outstanding loans, net income, total equity, and no interest expenses. Okay. Now here we see that all these uh, all these variables has p values greater than 0.05. Okay. So what it suggests that these these variables are not sufficient to explain the uh, dependent variable. Okay, so this was just a data set randomly we picked up and we tried to test. So it suggests that none of the variables are explaining the y, or what was our y, outstanding deposits. Okay, they are not able to explain it correctly, statistical. Okay, this might happen that in actual sense these are explaining, but here statistically it is not significant. Okay, so we will be rejecting all these variables for prediction of the outstanding deposits. Okay, so in the same way you can do the regression analysis for other data sets or other variables, where you can see that which variables are useful for the model and which are not. Okay, So by then you can decide whether to keep that particular variable in our model or not. Okay. Now, okay. After that, we will see few more examples. Dr. Firdous, how much time I can take?
We are having just 2 minutes.
Okay.
So 8:30, we were expecting to finish this, but you can take more 5 minutes. Then we can take at the end question and answer.
Okay. Okay. One more thing I will see. I will discuss, that is correlation. Okay. Because correlation and regression, they are very confusing. They become very confusing sometimes. Okay. In regression, we saw that how one dependent variable can be explained from some more independent variables. Okay. And in correlation, what we do is, in correlation, we see that how two variables are uh, associated with each other. Okay. In regression, there is a causal effect. Okay. If one changes, another one will change. Okay. So we will be able to explain in regression that if we change one particular variable, then how the other will change. Okay. There is a one, if there is one unit change in one dependent variable, then how the independent will change. Okay. But in correlation, what happens? We just see the association between two variables. It doesn't have any causal effect. Okay. If we see that if we collect the data of sales of ice cream in US and sales of shoes in India, so it might come that correlation might be one. Like correlation might be very positive, but it doesn't make any sense, right? So it doesn't have causal effect. It is just numerical values. We just check the association between them. Okay. So now let's calculate the correlation between any two variables. Input range, we choose to compare between total equity and non-interest expenses. Let's choose this. And we have labels in the first row. Names are, so output range, we can keep it in another worksheet. Okay, now there is no more options in this. Here is the result. So we see that correlation between non-interest expense and total equity is 0.988. It's very high. Okay, so correlation range of correlation is from -1 to +1. Okay, so if it is -1 means it is highly uncorrelated. Uncorrelated means they are not related to, they are reverse in relation. Okay, it means that if one variable goes in upward direction, then another variable go in the negative direction or downwards. Okay, and since we are seeing that it is 0.988. Okay, it means they are highly positively correlated. That is, it means that if one variable like total equity, if it is going upwards, then the non-interest expenses will go upwards. Okay, both will say move in the same direction. And suppose it was negative, then it will be reverse. Okay, one is going upwards, and so the another one will go downwards. Okay, and suppose the correlation comes around zero. Okay, close to zero, it means that there is no correlation. They don't explain each other. There is no association between them. Okay, so how we interpret this value, that the non-interest expenses and total equity, they are highly correlated, highly positively correlated with each other. Okay, so now I would like to conclude. I was not able to cover many of the things due to some restriction of time and other things. Yes, Dr. Firdous.
Yes, please conclude.
Yes, I have concluded. Please open for the audience if they have some doubt.
Okay, so I request all the participants, thanks for your patience. Now, kindly, if you are having query, you can raise your hand and we can call you one by one. If you are unable to speak on the mic, you can write in chat box. Quickly, we will be taking maximum 5 questions. So the session is open for the participants. Do ask a good question. I know we have started from the very basics. So some of the participants were asking that we were not expecting, that we have so common sense or simple concepts to be covered. But as we are gradually moving towards applied part, so I hope now at the end you will be understanding that how the session was developed.
There
So
is a
without
there is a
there is one question I will be speaking today. I will be reading questions. Sorry. Shriti has asked a question: why do we do t-text to text the difference between means? Why not simple compute it and check? So you can quickly reply to these questions.
uh,
So I think
okay. That question is very nice. Yeah, it's very natural to come to that conclusion that we can simply check the mean and go. So what happens is we give the value of alpha. Okay, alpha, how much we can give the leverage for every time we test and we don't get the results. Okay. If we have small data, we can simply compare whether the mean is same or not. But if we have a lot of huge amount of data, then what how we will be comparing? Okay, so scientifically we have to consider it whether there are some errors in the data, some data collection errors are there, some other kind of errors are there. Considering all those things, how you put up scientifically that whether the means are different or same, giving leverage of 5% or 1% or 10%. That's why we perform the t-test for comparing single mean or two mean. Okay, and there
so.
is a
There is one more question from
is all the
Harmandeep Kaur.
tests are based only on p-value. Okay, that's a very interesting question, and it is a very nice question. Actually, I wanted someone to ask. Otherwise, I was going to explain it later. Okay, now what is p-value? If you have noticed that while discussing about the measures of dispersion, we had several methods. Okay, mean deviation, standard deviation, variance. Okay, these are all were for one particular type of series or one particular type of data set. Okay, what if we want to compare it with some other data series or data sets which has different unit or different nature? Okay, so we arrived at one point, that is what was that, coefficient of variation. Okay, it helped us to differentiate between two different variables. Okay, now similarly p value is like a common point to compare different kind of test. Okay, for various for all the type of data set and all the situation we have value. Like if we are going to do the t-test, then we have some value, some kind of values. Okay, so we will check with the tabulated value, and then we will make a decision whether to uh, reject or accept the hypothesis that we have done. Okay, sometimes we are going to do z test, sometimes we will go chi-square test, sometimes we will go for the f test. Okay, so for every test there is a different kind of uh, different kind of table, different kind of differences, different kind of comparison. So overcome all these things, we have devised one thing, that is p-value. It concludes all of them. It is like a conversion to a single platform where we are able to differentiate them or make a decision on a single page. Okay, so this is nothing but this is just a translation, or you can say that transformation of our results in different various ways to one single understandable. Okay, we conclude it with p-value so that it will be easy for us to take a decision. If what if our result had f value 0.45, what you will do? You will simply go to the table, then again check, and then you will be rejecting or accepting the test. Okay, then again if you are going to do the t-test, then again the same procedure. Then if you are going to do z-test, then again the same procedure. Okay, what if I give you p-value? Every time you will be able to conclude with the value, just we will compare 0.05 or 0.01, and we will conclude that whether to accept or reject the value. So it is just a tool. It is just a conversion. Okay. You can go with the actual values or with the p values. It's up to you. Yes.
So there is last question we are going to take from Dr. Raja. He is
Dr. Raja,
writing, what is the difference between variance
comparison
comparison and mean comparison? And what is the difference between F-test and
and ANOVA. Okay. First of
he
all,
is
what is
asking,
the difference between variance comparison and mean comparison? It is simply that if you want to compare the means of a data series, it is mean comparison. And if you want to uh, test whether the variance of a data set is more or the other, it is simply just a comparison between the variances or the means. They both of them are different. Okay. And what is the difference between F-test and ANOVA? F-test and ANOVA both are not a different entity or similar. ANOVA is a test where we use F-test as a tool. Okay, one-way analysis of variance. Analysis of variance we do. How we do the analysis of variance using F-test. Okay, ANOVA is not complete without F-test. Including the F-test only, we will be able to perform ANOVA. Okay, in ANOVA, what we do, we compare the variances. Okay, we test the variances and comment upon the differences of means more than 3 means, 3 or more than 3. Okay.
we can take last question if anybody is having. Quickly, somebody is having any question, so they can write. Okay, so nobody is having no question. So before we will, I am going first to have, formal, vote of